Many thanks for inviting me to say something about this here at this conference. I work within the police, yes, but I'm not a policeman. I used to have a career at Linköping University for a long time, a statistician. But I kind of a little bit fed up with the university, so I moved full time to this forensic laboratory instead. We're dealing with, you could say, current cases and development in that context. I will talk about this probabilistic evaluation of forensic evidence. And this is more, you could say, orientation, what we do. It's not something new research or any new findings or so. It's just a description of how we do it in Sweden and in some other countries too, but very, very far from, let's say, a general approach within forensic science globally. What is forensic evidence, first of all? What do we mean by forensic evidence? Well, if you express it simply, it's scientific material that may bring information to a legal dispute. But this is, in a very broad sense, could be physical material of different kinds, could be organic material like human body fluids or tissues or anything, could also be inorganic material like gunshot residues, glass, whatever. But it could also be assessments of the physical and mental status of humans. This is also part of forensic evidence. In Sweden, we are a little bit divided here, in contrast to many other countries, where we divide the analysis between two institutes. Where I come from, one of them, the National Forensic Center, we work primarily with materials, you could say, from outside the human skin. While the other unit or institute, the National Board of Forensic Medicine, they work primarily with material from inside the human skin. So at my institute, we don't do autopsies, we don't do forensic toxicology of human fluids and so on. But we have, you could say, basically the same purpose, to assist in legal disputes about what the forensic evidence contribute in the discussions. And I will talk a little bit about how we report forensic findings at the National Forensic Center. We have many types of commissions coming from basically the police in Sweden. We belong to the police, but we also get the commissions from the police because we are a separate division within the police. And they could be of different kinds, these ones. We divide them into two main kinds. Either it's a commission that requires merely a descriptive report. What can you find on this hard disk, for instance? Or how did the recording of this movie, how was that carried out? Well, it's not a conclusion. It's just a description of the findings, but you need some forensic expertise to withdraw this information. The other part is inferential, where we are expected to provide a conclusion. And this can also be of different kinds in forensic science. Either you are asked for a classification. Does this white powder contain narcotic substances, classified narcotic substances, or not? There are several examples here. Conclusions on such questions could either be criteria-based. For instance, narcotic substances. It's more a kind of result that you simply see, well, do this result correspond with the criteria set out for being a narcotic substance? But they can also require some evaluation to be made. I will come to that. Then we have what is referred to as source attribution, probably the most common kind of commission given to a forensic laboratory. And we have activity attribution, which is a little bit more complicated then. And then we also have something called case assessment. But these evaluative reports with conclusions, then we deliver a conclusion using the Bayes factor. So we adhere to, you could say, Bayesian inference when we do this. And this evaluative reporting then, well, the rationale behind it is Bayes theory. Bayes' theorem, period. It's a rationale behind all this stuff. And the point is, what parts of Bayes' theorem is it then that we actually report? Well, normally we must work with at least two propositions or two hypotheses about the forensic evidence material. One of them stems from, you could say, the prosecutor's conjecture about the evidence material. And the alternative one would simply be formulated as the collection of all alternatives to the prosecutor's conjecture. That would be the most natural alternative hypothesis. And then we have the forensic findings. Those are the ones that are exposed to evaluation. And Bayes' theorem, in that sense, we use the so-called odds form theorem, which is, you could say, designed for making decisions, where you put two hypotheses against each other. And you can see that the posterior odds is built up by the prior odds, and what we'll come to is the Bayes factor. And we look at Bayes' theorem on odds form in particular. Now we have talked about priors and prior probabilities, and here we're talking about prior odds, which simply are how much speaks for the prosecutor's conjecture against how much speaks for the alternative in advance, before you take the forensic evidence into account. And this, we say, is the domain of the legal fact finder. It's not the domain of the forensic scientist. Should have no opinion about that. Then the term in the middle here is what is the domain of the forensic scientist. This is about the likelihoods of the forensic findings, or the likelihoods of the two hypotheses in light of the forensic findings. And those two multiplied together would give you the posterior odds, which is, again, you could say, the domain of the legal fact finder, although the fact finder is assisted by the conclusion from the forensic investigation, but should combine it with the prior odds. Because of that, it is also the domain of the fact finder. And that ratio in the middle is what in the literature is very often referred to as a likelihood ratio, although you might not see it immediately. But it is a likelihood ratio if both these hypotheses or propositions are simple, means that they depict one isolated scenario each, which is quite rare in forensic science. Otherwise, we refer to it as a Bayes factor. And it's a Bayes factor for the numerator proposition hypothesis against the alternative, the denominator hypothesis. If you should be very, very strict, the definition of a Bayes factor is simply the ratio of the posterior odds to the prior odds. And that may lead to, you could say, different forms. It's not always as simple as a ratio here of two probabilities. There could be other types of probability measures involved, and you can express the likelihood in terms of single probabilities. So the challenge is to assign this Bayes factor. And as an example here, we can take the source attribution of a recovered shoe mark, where the prosecutors or the main hypothesis would be that the suspect's shoe was used to make the recovered mark. The alternative, well, can simply be expressed that some other shoe was used to make the mark. If we discard the possibilities of programming an electronic device that could send into a crime scene and sketch a shoe mark on the floor. But this is, today, we don't consider this to be a realistic explanation to it. So we assume that it must have been a shoe here worn by someone. The forensic findings, well, very often we look at the mark as such. We consider that maybe a match in sole pattern between the mark and the sole of a suspect shoe. Could also be a correspondence in size, if we have a large enough mark. But more importantly, there may be so-called acquired characteristics from a shoe that have left corresponding details in the the recovered mark. For instance, damages or wear pattern and so on. And this, of course, have higher value of evidence. So when we then assess the Bayes factor, we have, well, in the simplest case, we assess or assign two probabilities. To assign the findings, the probability of the findings, given that the main hypothesis is true, well, that's usually quite simple. Because if we assume that the suspect shoe made the mark, then all correspondences are expected. So very often this probability is assigned to be very close to 100%. But assigning the probability of the findings given that the alternative hypothesis is true is a challenge, and is the most important part here, because this, you could say, decides the value of evidence. So a matching solve pattern and corresponding size, well, they're actually quite rare findings. You might think that they are not. You might think that, well, everybody uses that shoe, so it must be quite a common solve pattern. But there are several independent studies that have shown that the most common contemporary solve pattern has a relative frequency around 1.5%. And I mean, the fashion changes with time, but anytime you go down and look at this, you will find, well, the most common solve pattern is about 1.5% of all shoes. So combining then shoes and solve pattern, you subjectively assign this probability, the joint probability here, about 1%. And then have a correspondence here in a detail and aware pattern. Well, this is definitely subjectively assigned. You have no databases to look at here. Well, you might have, but very much it comes to the forensic scientist expertise and experience on this, and how to deem on how low could this probability be. And in a particular case, you can deem it to be less than 0.5%. Not that uncommon. So if you then assume conditional independence between these parts of findings here, you might end up with an assigned probability that is less than 0.005%. So putting these together then means that you assign the Bayes factor to be at least 200, saying that the forensics findings are more than 200 times more probable if the suspect's shoe was used to make the mark compared to if another shoe made it. And this, as you can see, this definitely reflects the uncertainty involved. And the greatest source of uncertainty here is the prevalence of the forensic findings in the population to which you do the comparison. While as measurement uncertainty is negligible in that sense. This is the main source of uncertainty when it comes to the attribution source. But does the legal fact finder understand this, and can they use it? That's the interesting question. Well, it requires that the fact finder understands what their prior odds are, and basically that they should be able to express them at least approximately numerically, because we are giving them a kind of number here. We try to simplify this. You can simplify the reporting by not reporting assigned value, but instead you place that value on a scale. And this is what we do. We practice a scale of conclusions where we use intervals of Bayes factors and just report in which interval are we. And the requirement on forensic scientists is that you must be convinced that you have passed the lower limit here. But you're not obliged to be more precise than that. So you're not obliged to say whether it's in the middle of the interval or the upper interval and so on. And this also gives, you could say, benefit of the doubt to the defense that I can use the lower limit. And you can say nothing about that. It's good for the forensic scientist not to be required to be too precise. It's good for the defense that can actually use the conservative number of the lower limit. This is the rationale behind using a scale. But there can still be issues with communication in court, of course. It's difficult to focus too much on the Bayes factor, despite that this is what the forensic scientist should report. So, well, given statement in court, you can get a question here. Was it this gun that fired the bullet? Well, the forensic findings support that the gun fired the bullet with level +2 in our scale. So do you mean that you're not 100% sure that it was this gun? Well, I do not address the proposition. I only address the forensic findings under each proposition. And they are much less probable if there was another gun that fired the bullet. But then you have this scale with pluses and so on. Then, since you have up to +4 in your scale, shall I take it that your +2 means you are 50% certain that the bullet was fired from this gun? A very common misunderstanding, and you use a scale with numbers. Okay, so if we instead address just the Bayes cycle, try to address the entire Bayes theorem to explain how this goes together, then you can say, as a forensic expert, the reported conclusion +2 here means that the forensic findings are at least 100 times more probable if this gun fired the bullet compared to if another gun fired it. Hence, you should multiply your prior odds with 100. What is that? Prior odds. Well, your prior odds are how much you believe that it was this gun compared to how much you believe it was another gun, based on other information you have in your investigation. But what I believe shouldn't affect your conclusion, should it? My standpoint is that the conclusion from a forensic scientist should be objective and self-standing. Well, it is objective, but it can never be self-standing when it comes to the probability that this gun fired the bullet. It's always relative to the propositions, because this is how it works. But I do not follow this at all. Must I be a mathematician to understand your conclusions? So I mean, this is the, you could say, clash between mathematics and legal enforcement and justice. But then a final question here. I presented something that seems very simple, but using a word that I learned from Jay here, is this actually the correct way of using Bayesian inference? If you look at this example here with the recovered true mark, again with these two hypotheses or these two propositions, we can clearly see that the main hypothesis here is simple. It just points out that this specific shoe was used to make the mark. Can only be done one way. But the alternative is very composite. Some other shoe. There are many, many shoes here. So looking at this correctly, or putting this up correctly, means that the ratio of these two probabilities, well, it's still a single probability in the numerator, but in the denominator, it's could say a weighted sum of probabilities of the forensic findings given each of the possible shoes that can have made the mark. And the weights are simply the probabilities that this particular shoe among the other shoes made the mark. And the problem is that this is, of course, the domain of the forensic scientist, because the forensic scientist can deem on how probable it would be to get these forensic findings given this particular shoe. But it's definitely not the domain of the forensic scientist to tell whether that particular shoe has a certain probability of being the shoe that made the mark. This is the domain of the fact finder. So this means actually that any value in this interval here, you see that the denominator stands in both limits. But here, well, the only thing you can do as a forensic scientist is to maximize the probability of the findings, given maximizing overall possible shoes, you maximize that probability. That would be the lower limit. And if you minimize it, it would be the upper limit. And all values in this interval, all single value in this interval is a Bayes cycle. And no value outside this interval can be a base factor. So it's not as simple as a forensic scientist can assign a particular base factor. This is the base factor. If any of the hypotheses involved is composite. And this is a newer result due to JME, was published this year. And we expect that we get some, I could say, angry reactions to it, because it stirs up, you could say, a model that has been built for 30 years. But we are challenging it using this.
Can you explain the last part in denominator again?
See, if you look at the probability, if you look at the formula up here, I mean, since the forensic scientists cannot say anything about those relative prior probabilities of each particular shoe. You know that they sum up to 1. So then you can take the minimum that's outside the sum, or you can take the maximum, and so you get the limits. Yeah, thank you.